of transferring energy from one place to another. There are two types of waves: longitudinal waves and transverse waves. What are longitudinal waves? Longitudinal waves are when the particles travel in the wave motion. And transverse waves are when the particles travel perpendicular to the wave motion. So sound waves are an example of longitudinal waves. Sound waves have compressions and rarefactions. Let us look into a diagram of compressions and rarefactions. Here is a longitudinal wave, and this is the wave direction. This part, where the particles are close together, is called as compression, like here as well in the wave. The part where the particles are spread apart is called rarefaction, as like here in the wave. Compressions have greater pressure than normal as the particles are closer together, and rarefactions have less pressure than normal as their particles are spread apart. Hence, sound waves are also called as pressure waves. Let us look on to the diagram of a wave. Here is the diagram with the labeled parts. The length from the top of the wave to the line in between is called the amplitude. Not only this is considered as an amplitude, it can also be the length from the line in the between till the end of the wave as amplitude. Wavelength. This is the sign for wavelength called as lambda. A wavelength is the distance between two successive crests or two successive troughs. What is a crest and a trough? Crest is simply the top part of the wave, and trough is the bottom part of the wave. So two successive troughs will be considered as a wavelength, or two successive crests will be considered as a wavelength. How do we know the starting point and the ending point of a wave? As you can see, this is where the wave starts. Where it starts from the line in the between, as it goes and comes back to the line back in the between, is considered as one wave. From here to here will be one wave. From here to here, one wave. So we have two now. From here to here, the third wave. And we have half a wave here. In fact, less than that. So this will be the diagram of the wave. In this diagram, we can see that we have two different diagrams, where this one has a shorter amplitude than this one, which has a taller amplitude. What is the difference between both of them? The one with a short amplitude has a quiet or a soft sound, whereas the one with the taller amplitude gives a loud sound. The audible range for human hearing is 20 Hz to 20,000 Hz. Thank you very much for watching this video. I hope you understood. If you have any questions, put them on the comments down below. Thank you.